Okay, so when you look at section 4.4, which says using corresponding parts of congruent triangles, what you have to do is prove. So number one, once you prove triangles congruent by AAS, ASA, SSS, or SAS, those are 4 methods to shorten up, then you can prove, let's not make that number 1, let's just make that a star, then you can prove any corresponding parts of the triangles are congruent. So, same exact proofs that you've been working with, identical proofs you've been working with. The only difference is the proof statement is different. The proof statement, instead of saying that the triangles are congruent, the proof statement is going to say prove that angle A is congruent to angle F. The only difference, so one additional step of these proofs. So, let's just start with, once you have that written down, I'm going to skip. I'll give you a minute to write it. And get it all written down, because I'm going to check everything. Remember all of that? I'm going to check it all. Okay, so let's look at this proof right here. So now this is a proof that's going all the way back before we did our shortened proofs, just to let you know. It says complete the steps. So given that AB is congruent to AD, so they have those single tick marks, that's a direct side congruency. Then BC is congruent to DC, that's a direct side congruency. Now, we can prove that AC is congruent to AC all by ourselves, can't we? Why? They've proven more than they have to prove the triangle is congruent. So they've gone all the way back. Remember how we originally started doing triangle congruence proofs? We had to do 6 corresponding parts were congruent, and then you could finally say the triangles were congruent. Remember those? Horrible, awful ones? Well, this is kind of what they're doing here, which I'm not going to make you do that. So this is a reflexive property. And then that's another, so we could prove the triangle is congruent right now by SSS. But then they also give you that angle D is congruent to angle B, so that's an angle. Then DAC is congruent to BAC, DAC is congruent to BAC, that's another angle. How could I prove that angle DCA is congruent to angle BCA? How could I prove these? Once I know that those 2 angles are congruent, how do I prove those angles are congruent? The third angle theorem, right? And so that gives us all 6 parts that are congruent. So here, this is all that they've done. So AB is congruent to AB. BC is congruent to DC. They got that out of the given. Bless you. So this is my side and my side. There's 2 of them. Then AC was congruent to AC. We got that ourselves using the reflexive property of congruent segments we like to add on. Then angle D is congruent to angle B from our given. And DAC is congruent to BAC from our given. And so that's another side up here, and these are 2 angles. So there's 5. Our 6th one was the one that we came up with here. Angle DCA is congruent to angle BCA. And they wrote the third angle theorem. You have to write, if 2 angles from one triangle are congruent to 2 angles in other triangle, then the third angles are congruent, or something congruent. Pretty much have to say something like that. And then that gives us our sixth piece. The whole point of this proof is to remind you that all corresponding parts of congruent triangles are congruent, some way or fashion. So the two triangles, ABC and triangle ABC, are congruent, and they put here definition of congruent triangles. I'm going to put in here if all corresponding parts of two triangles are congruent, then the triangles are congruent. That's the important thing you need to learn to write. But we're going to write it kind of slightly different to our proofs that we get here. So if all corresponding parts of two triangles are congruent, then the triangles are congruent. Notice they didn't use AAS, ASA, SSS, or SAS. They didn't use any of those here. They certainly shortened the proof in half. But let's look at this one right here. So notice the change in proof statement. It does not ask you to prove the triangle is congruent. It asks you to prove two parts of the triangle is congruent. Before you can prove any parts congruent, you must prove that the triangles are congruent first. So notice down here, they've done the whole proof here for you. We're going to walk through it. Notice down here, here's your triangle congruent statement. There's the parts congruent. This must come before this. So anytime you have parts of a triangle that are congruent, you must precede it with a triangle congruent statement. So we really have the same proof. It's just different. So if I were you, please take your paper and fold it so that we don't look at all the other stuff that's in there. I don't need to look at all that. We're just going to go ahead and do the proof and walk through it. So there's a nice little proof. So let's look to see what they gave us, and let's look to see what else we can prove. So they gave us that BA was congruent to DA. Here they've tick marked BA and DA. That's a direct side congruency. Then CA is congruent to AE, direct side congruency. Before we can prove parts congruent, we have to prove the triangles congruent. And so right here I'm going to put an arrow. Before that has to come the triangle congruency statements. Now here's the answer to your question, Olivia. Here you can put your triangles in whatever order you want to, but you have to have corresponding angles line up with corresponding angles in the triangles. So if I choose to do ABC. We're going to come up with this one in a minute, because we have to kind of get at least one set of angles congruent first. Maybe. Because we don't have our third side. So what's going to be our third piece here before we finish our triangle congruency statement? What's going to be our third piece? Do I have a shared side, or do I have vertical angles? So this angle right here and that angle right there are vertical. So I can say that angle CAB is congruent to angle EAD because vertical angles are congruent. And that's going to give me an angle congruency statement. So then look at your triangle. Put your fingers on those two sides. Is that angle in between the two sides or not? Yep. So we are going to prove these triangles congruent right here by SAS. So now that I have one of my angles, doesn't angle A correspond to angle A on the other triangle? So if I start off with A, I'm going to start off with A there. Then angle B was the one that came next. Angle B and angle A have that single tick mark side in between them, but doesn't angle A and angle D have that single tick mark side in between them? So D has to correspond to B. That leaves us with E. Now you could have switched up ABC and written it BCA, but then you'd have to switch that up and make sure that corresponding angles align with each other. So everybody's could be different. Once I've proven the triangle is congruent, I can immediately go to any corresponding parts, and there are 6 corresponding parts to each of these triangles congruency statements. They chose one of them. Your answer, 100% of the time, to any of these, you're going to write here as a shortened form, CPCTC. Learn it because it'll help you write out what it really means. CPCTC. We're going to write it out down below. CPCTC. Lots of C's in there. CPCTC. You'll see the method to my madness in a minute. But you're not allowed to write that in your proof. That's just your pre-proof point. Okay? That always goes with any corresponding parts. It could be sides. I mean, they could have said BC was congruent to DE for your proof statement. Doesn't matter whether it's angles or sides. Your reason for that, once you've proven the triangle is congruent, is going to be CPCTC. So here we go. VA is congruent to DA. That's our side over there, and that was in our given, right? And so that's our side. So I'm going to check off my S. Now, do I agree with what they did here? No, I want these ones switched around. I want those ones switched around. Me personally, if I were doing the proof. So if I were you, I'd cross this out. And I would put angle CAB is congruent to angle EAB. Why would I do that? Exactly. So I wanted to spell out SAS on the side. So the reason that we put for that was vertical angles are congruent. So then I can mark off my A. And then I'm going to cross this one out and put CA is congruent to EA. And that was from our given. And that is our S. So boom, immediately when we hit SAS, next should come that triangle congruency statement. And didn't they write theirs differently than I wrote mine? They wrote CAB. But notice that my C and my E line up, their C and their E line up. Their A and their A line up, and so do my A's, and so do my B's and D's. So this is acceptable as well. And the reason for that is exactly what we put up here, SAS postulate. Now, immediately after writing any congruence statement, triangle congruence statement, or any corresponding parts of those triangles, it just happens that that's exactly what we've asked for, and your reasoning behind this is C corresponding P parts of C congruent. You can use a congruent symbol for that later. So corresponding parts of congruent T for triangles are C congruent. CPCTC. Corresponding parts of congruent triangles are congruent. It'll help you remember it. And done. So the only thing different about these proofs, they're identical, is you've got one more statement. That's it. So try the proofs, try your assignment,